Okay, Assalamualaikum. Today we're going to present our first assignment, which is Battery Energy Storage System, BESS. So first of all, my name is Muhammad Rizal bin RAOF.
My name is Muhammad HAZIQ bin KHAIRIL AZRI.
And my name is Ashraf Farhan bin SAFIEE.
Okay, next. So what is BESS and how it works? Battery Energy Storage System, BESS, is a technology developed for storing electric charge by using specially developed batteries. The underlying idea being that such stored energy can be utilized at a later time. Enormous amount of research has led to battery advances that has shaped the concept of battery energy storage system into a commercial reality. Second, battery energy storage systems are a subset of energy storage systems. Energy storage system is a general term for the ability of a system to store energy using thermal, electromechanical, or electrochemical solutions. A BESS typically utilizes an electrochemical solution. A battery energy storage system is a subset of energy storage systems using an electrochemical solution. In other words, a battery energy storage system is an easy way to capture energy and store it for use later. For instance, to supply power to an off-grid application or to complement a peak in demand. They are usually not used to replace grid power completely, but instead used to offer short-term solutions in applications where access to grid power is intermittent or the use of a generator is unsuitable due to noise or pollution concerns. Another application of energy storage system is the management of energy generated by intermittent sources, such as solar panels. A variety of different battery technologies is available for use in battery energy storage systems. However, in recent years, solutions using lithium-ion batteries have grown in popularity, driven by the benefits of energy storage system, such as their long working life, wide operational range, lightweight structure, high energy efficiency, and crucially, the falling cost of the technology. These, combined with the low total cost of ownership and sustainability, make them attractive for several applications. So, the working principle and process BESS. Briefly explain the basic working principle and processes BESS. First, if combined with solar power, the BESS system will store excess solar power so that it can be used at another time, increasing the rate of self-consumption and reducing electricity purchased from the grid or not generating capacity on the grid according to requirements of EVN. Second, if not combined with solar power, the BESS system can store electricity from the grid at a time of low electricity prices and generate it for use during times of high electricity prices, like generating as much as saving to save electricity costs. In addition, the system also stores electricity as a backup power supply in case of power failure. The main component and its function. The first one is bidirectional converter. Bidirectional DC to DC converter is used as a key device for interfacing the storage devices between source and load in renewable energy system for continuous flow of power, because the output of the renewable energy system fluctuates due to change in weather conditions. Bidirectional DC to DC converters work in both buck and boost mode and can manage the flow of power in both the direction between two DC sources and load by using specific switching scheme and phase-shifted control strategy, and hence generated excess energy can be stored in batteries or supercapacitors. The second one is battery bank. The battery bank is one of the most important components of standalone systems, storing the wind energy surplus of high wind speed periods in order to cover the energy deficit in low wind speed and high load demand cases. The third one is EMS, which is Energy Management System. This is responsible for monitoring and control of the energy flow within a battery storage system. And EMS coordinates the work of a BMS, a PCS, and other components of a BESS. By collecting and analyzing energy data, and EMS can efficiently manage the power resources of the system.
Okay, another three main component and its function. One is a power transformer. A power transformer is a static device used for transforming power from one circuit to another without varying the frequency. The transformer is used to step up the low voltage from the inverter side to the MV of the grid side. The second one is the HVAC, which is the control temperature in the room. And HVAC system is designed to control the environment in which it works. It achieves this by controlling the temperature of a room through heating and cooling. It also controls the humidity level in the environment by controlling the movement and distribution of air inside the room. The last one is AC and DC switchboard. The role of a switchboard is to allow the division of the current supplied to the switchboard into smaller currents for further distribution, and to provide switching current protection and metering for those various currents. Next. The next is what is the advantages of battery energy storage system. One of them is the modular and customizable system. The second one is the parallel operation with different power sources. On-grid and off-grid operation. Another one is the remote monitoring and control, complete energy management, real-time operation setting. The others is easily integrated with existing electrical system, integration with renewable generation sources, high storage capacity and high energy density. There's also a few disadvantages of BESS. One of which is a thermal runaway. A thermal runaway is a cycle in which excessive heat keeps creating more heat, and it is a major risk for lithium-ion battery technology. It can be caused by a battery having internal cell defects, mechanical failures, damage, or overdamp. Okay. It can be caused by a battery having internal cell defects, mechanical failures, or over voltage. This led to high temperatures, gas build-up, and potential explosive rupture of the battery cell, resulting in fire or explosion. Without disconnection, thermal runaway can also spread from one cell to the next, causing further damage. Another one is difficulty of fighting battery fires. Battery fires are often very intense and difficult to control. They can take days or even weeks to extinguish properly, and may seem fully extinguished when they are not. Another one is failure of control system. Another issue can be failure of protection and control system. For example, a battery management system (BMS) failure can lead to overcharging and inability to monitor the operating environment, such as temperature or cell voltage. The last one is sensitivity of batteries to mechanical damage and electrical transients. Contrary to existing conventional battery technology, some batteries are very sensitive to mechanical damage and electrical surges. This type of damage can result in internal battery short circuits, which led to internal battery heating, battery explosions, and fires. The loss of an battery can rapidly cascade to surrounding batteries, resulting a larger scale of fire.
Okay, next, so the power plant battery energy storage system. So the capacity is 25 megawatt over 12.5 megawatt hour BESS. Location at Tynamouth, Newcastle, in United Kingdom. Project is supported by a 4-year contract with British Utility National Grid to provide grid electricity service, and using a lithium-ion battery provided by Samsung. So the certification battery energy storage system. A battery energy storage system BESS must comply with national and international standards specific to the region and industry. For the first, UL 9540, the standard for energy storage system and equipment. 4 is the new standard for safety of energy storage system, which includes electrical, electrochemical, mechanical, and other types of energy storage technologies for system intended to supply electrical energy. The standard covers a comprehensive review of energy storage system covering charging and discharging, protection, control, communication between device, fluids movement, and other aspects. Next, IEC. IEC 60086 is an international standard that encourages manufacturers of battery to ensure that their batteries are interchangeable according to standard form, fit, and function. This is intended to help end users as well as manufacturers of devices that use your batteries. Certification of the IEC battery standard shows the battery complies with the standard. What's more, interchangeability means that the battery can be used in a much wider range of products, meaning you can boost adoption and revenue as a result. For third certification is NFPA 70E for electrical safety. In a need to respond to electrical hazard in the workplace, the National Fire Protection Association developed a standard to provide a guidance. NFPA 70E standard for electrical safety in the workplace is designed to provide workplace for employers that is safe from electrical hazard. The standard objective is to provide practical safety resulting in a reduction of injury associated with electrical risks such as arc flash. For fourth certification is IEE 2030 Smart Grid Interoperability Reference Model Guidance. Application of this standard includes: first is a stationary battery energy storage system BESS and mobile BESS. Second, carrier of BESS including but not limited to lead acid battery, lithium ion battery, flow battery and sodium sulfur battery. Third, BESS used in electric power system EPS also provided in the standard are alternative for connection, including DR interconnection, design, operation and maintenance of stationary or mobile BESS used in EPS. Introduction, overview and engineering issues related to the BESS are given. Finally, number 5 is from CRIM, MS IEC 62133 ratio to 017. Is a secondary cell and battery containing alkaline or other non-acid electrolyte safety requirement for portable sealed secondary cell and 4 batteries made from them for use in portable application. So lastly, this is a reference for this subtopic battery energy storage system. So that's all. Thank you.